We have our reminder, we just talked about that. An expression is not considered simplified if it has negative or zero exponents. So when I mark something wrong on an assessment and it has a negative exponent still in it or a zero exponent in it, you don't get to get mad at me because it's the rule for simplifying. Okay, so let's start with our, notice now, we're not doing where we are substituting into algebraic expressions and getting an actual value. We're just simplifying algebraic expressions. No different than if I have the algebraic expression, something like this. 3 times x plus 4. That's just an algebraic expression. Can it be simplified? Yeah. What can it be simplified to?
3x plus 12.
3x plus 12. So what we're doing is we're just taking a different type of algebraic expression and simplifying it. So we're not going to find a value for it. We're going to actually just get it where, so we say can't do anything else to it at this point. Okay? So let's start with our 2 times r to the 0 power times m to the negative 3. And you have to show work, how you get there, how we actually are going to get there. And we're going to show the process that actually happens, even though there are some shortcuts. And I'm going to guess by now you might have discovered some shortcuts for these negative exponents. And so, but let's show why they actually happen the way they do. So 2 times, what can r to the 0 power be renamed as? 1. So here's what you get to assume in all your homework right now, that the variable is not 0. In other words, because remember, we can't take 0 to the 0 power and get 1. So we're going to assume that the variable never represents 0. It's some other base other than 0. And then how can we rename m to the negative 3 power? Courtney?
1 over m to the 3rd power.
1 over m to the 3rd power. Okay, well now since we have that fraction, let's make these other ones into fractions also. And let's multiply across. 2 times 1 times 1, 2. 1 times 1 times m to the 3rd, m to the 3rd downstairs. So, do you think we can simplify that anymore? Is there anything that can be divided out upstairs that could also be divided out downstairs? No. Do we have any negative exponents? No. Do we have any 0 exponents? No. So we could say this one is done. So compare that in your notes if you get the same answer. So any questions about that one? Okay, then let's move on to 4b, where we have r to the negative 3 power over 7. Is that simplified already? Why not? What's the problem? It's a negative exponent. So we're going to rename that negative exponent. So we're going to say the numerator, we're just going to worry about the numerator right now. The numerator can be renamed as 1 over r to the 3rd power. We're not getting rid of the fraction yet. We're just saying rename that numerator so it doesn't have a negative exponent. So that's all we've done. Now we're going to see why the answer is going to end up the way it is, even though there is a shortcut for this. 1 over r cubed over, so in other words, our numerator is a fraction, over 7. 7 is our denominator. What's really going on here? What kind of, how can we set this up? What other type of problem do we really show it as? It's another way to show this. We can show it as multiplication, but let's change first it to writing it with the division symbol. In other words, 1 over r cubed, our numerator. This big fraction bar means divided by 7. So just writing it with the fraction bar being replaced, the main fraction bar being replaced with the division symbol, because they mean the same thing. Now we say, okay, when you get a fraction involved and you're trying to divide, it's really handy if you change it to multiply by the reciprocal. So the first term does not get changed. The first factor does not get changed. But the other one changes, we change the division to multiplication, and 7 changes to its reciprocal. 1/7. And now we can multiply across. So 1 times 1, 1. R cubed times 7,
R cubed.
7R cubed. Yeah, we put the 7 out front and the R cubed behind it. Can that be simplified anymore? Anything else that can be divided out of that numerator, that can be divided out of that denominator, that would be useful. Okay? Again, check, did you get that answer in your own notes? Did you get 1 over 7R cubed? Okay, now, anybody at this point, and maybe you've got, in your notes you possibly even used this shortcut, I don't know. Anybody know a shortcut that we could say, well, here's what really happens? Well, I'm certainly not going to point it out to you if you haven't found it yet. Because then that's what you're just going to start doing without having an understanding of how it works. Okay, cool. Let's just keep going here. Okay. Considering what we just did, what do you suppose we're going to do in this next problem? Are we going to need to rename that numerator right now? No, it doesn't have a negative exponent. It doesn't have a 0 exponent, so we're going to leave the numerator as it is. It's g to the 4th. Do we need to rename the denominator? Yes, as what? 1 over h to the 6th power. So we've gotten rid of the negative exponent that was in there. Now we're going to rewrite it with a division symbol so we can see what's really happening here. We have g to the 4th being divided by a fraction. Well, what do we do now? Change it to multiply by the reciprocal. The reciprocal of which one? The g over 4? The g to the 4th, I mean? Or the 1 over h to the 6th? 1 over h to the 6th. What you're dividing by, that's what becomes the, when we change to multiply. So the first one we don't change. What you're dividing by changes to its reciprocal. G to the 4th can be put over 1. And what do we end up with? G to the 4th times h to the 6th. G to the 4th, h to the 6th. Yeah, we can write it without the multiplication symbol. And when you have just ones downstairs, are they necessary? No. So there's our answer. G to the 4th, h to the 6th. Again, that one should be in your notes also. Compare, how did you do? Okay. They always look easier when we're doing them together in class, don't they? So you got to do them on your own. Yeah, that's how it works. It's like, oh, I get this. And then you're working on the homework and you're like, uh-oh, what do I do here? Call the Graham? No, I don't want to talk to her. I'll just try and wing it. Okay. So let's take a look at some more where they get maybe just a little bit trickier. They didn't have these in, but yet I love this. This is what they do. Oftentimes in this book, especially as we go on, it gets harder. They do some examples in the book, and then in the homework they have a whole bunch of them that aren't even close to what the examples were in the book, and you're like, never saw this before. Jason?
Can't you just, if it's a negative exponent, can't you just put it on the bottom and make it quicker?
Oh, you might have discovered the shortcut that I was talking about, huh? Jason, you're saying, why can't you just take the one wherever the negative exponent is? So if the negative exponent is upstairs, you just move it downstairs? And it becomes positive? Or does it stay negative?
It becomes positive.
Becomes positive. Yeah, you can. How about, is there any other shortcut you think at this point? Okay. So in this next one, we're just going to first write it out. We're going to consider that there's multiplication going on between these. So we're going to write it as a multiplication problem. We're going to actually include the multiplication signs, I mean. And then how can do we need to rename that 3/4? I guess I should have asked. No. Do we need to rename that x to the negative 2? Yes, as 1 over x squared. Do we need to rename y to the 3rd? No. And here's what happens. We start thinking, When there's a negative exponent in it, we start getting carried away and we start renaming things we don't need to. If it doesn't have a negative exponent, leave it alone. Don't rename it. I'm just going to make it into a fraction and put it over 1. So now I can multiply across. 3 times 1 times y cubed.
3y.
3y cubed. 4 times x squared times 1. 4x squared. Okay, we don't say we're done until, remember, we run through all the things. Is there anything that can be divided out of the numerator that could also be divided out of the denominator? Other than 1, because dividing out 1 doesn't get us anywhere, right? Okay, so Cam, any negative exponents left? Any 0 exponents left? Okay, runs the test of being simplified. There's our answer. Okay. The next one, I know Chaser wants to use his shortcut, but he's going to work through the steps of this. We're going to see why the shortcuts might work. Okay? So, numerator. Does the numerator need to be renamed?
Yes.
Sure does. Okay, so 1 over a to the 4th. The numerator over, so now remember that we have a fraction within a fraction. The denominator, does the denominator need to be renamed?
Yes.
It does. It has a negative exponent. So 1 over b squared. Just like we did up above, when we have a fraction within a fraction, whether there's 1 fraction or 2 fractions within our fraction, we're going to rewrite it as a division problem first. So 1 over a to the 4th divided by 1 over b squared. And now we change it to multiply by the reciprocal. So 1 over a to the 4th times b squared over 1. And the final answer is
Squared over a to the 4th.
b squared over a to the 4th. Can it be simplified anymore? Anything can be divided out the top and the bottom? Negative exponents? 0 exponents? It's going to be asking that, but you should run it through that test every time so you don't get it wrong because you just quit simplifying too early. Okay. Any other shortcuts you've discovered right now, then, Chaser? Not yet? Okay, so the next one is a multiplication in the numerator, which makes that a little trickier, doesn't it? And then we have a denominator. So again, we'll just rename anything that needs to be renamed. Does m to the negative 3 need to be renamed? As what? 1 over m to the 3rd. We're still working upstairs in the numerator. Does n to the 0 power need to be renamed? As what? 1. Over 1. P to the 0 power is also 1. Well, we're not even going to multiply across because when there's multiplication going on, we can cancel those 1s, can't we? And the final answer is 1 over m to the 3rd. Because remember, anything that's up in the numerator can just be pulled out, right? And stand alone. So, here we go. Okay, how about you try that last one on your own? See what happens.
Okay.
And if you have the variables turned around, then the ordered on the denominator, that's not a huge deal, but however, like alphabetizing also. Letters, says, oh, letters are in alphabetical order. Do you agree with me? Anybody want to challenge me? So the denominator did not need to be renamed. So don't rename anything that doesn't need to be renamed. Okay? So any questions about that one? I saw a lot of people having to change their answers on it, so you're just going to change it and trust me? Is that the deal? You really trust me that much? My kids did when they were in high school. They do now as adults, but in high school they didn't do anything. Oh, okay. Then I guess we'll be done.